down from the top of the glass. So you can see actually over here, there's no dirt. It all starts from this horizontal edge trim. Now, what happened over here, and we spoke to the client and the client's facility management team, and they're very unhappy. They told us they cleaned the facade, and 1 week later, the facade again looks like this. It's dirty, dirt strikes, so they're very unhappy. Now, what happened over here? This is pretty important to understand the local climate conditions. This is the facade system that actually got installed, and this is what's actually happening on site. You can see over here, there's condensation. So around the edge of the glazing, there's the so-called aluminum edge trim. Now, exactly at this edge trim, the moisture that's actually within the air starts condensating. You can see all the water drops over here. Then at the bottom edge over here, this condensated water starts running down. As I said before, a lot of dust, so we always have a little bit of dust on the glazing. If then small drops of water start running down, these small drops of water pick up the dust, and you get all of these kind of strikes going down. And this is purely by a design error. I wouldn't say error, it was not taken into account because this system is used quite often in the United States. It's a cheap system designed about 30 years ago. And this kind of Northern American cheap system was just put in the Middle East and installed, full stop. So this system is actually thermally unbroken. So there's no thermal break in this aluminum edge trim, which means on the inside is about 24 degrees Celsius, it's cold. On the outside it's hot and humid. So this cold temperature goes through the aluminum, through this non-thermally broken extrusion, right to the outside. So this piece of aluminum is pretty cold. So this is why it actually starts condensating and all this trouble started. Yeah? This is just an example of a design that shouldn't have been done here in the Middle East. And I'm also going to show the kind of alternative proposal that we would propose if it would have been asked by the client. And on this project, the architect, as far as we know, did not use a facade consultant. So you can see over here, this is the kind of base design, and our proposal would have been just putting in small thermal isolators, put in thermal bridges, which means that the whole cold flow from the inside to the outside is not happening anymore. It's actually thermally broken, which means that the surface temperature of this aluminum edge trim would be much higher compared to the original design, avoiding condensation on the external actually framing. And you know, just putting these thermal breaks in is actually state of the art. The technology is there. It's not a lot of cost plus. It's just someone needs to tell to the architect and the client, this is the best way of doing it. And I think it's a nice example how things should not be done, and some people do not take into account the local climate over here. Some more items, quality control. We see a lot of things going on site. You can have the best design team, the best tender drawings. If there's not a specific facade specialist or consultant on site doing QA/QC, quite often things do go wrong. So this is a glass unit where water started ponding within the glass. So I was very surprised, never seen this before. Now on this project, there were some so-called breather tubes to actually pressure equalize the cavity within the glazing. And on site, the people need to cut this breather tube and seal it off. You can see over here, this was not done properly. So there was a big quantity of glass panels failing, meaning they started fogging on the cavity after a couple of weeks. So very big error, and a lot of glass panels had to be replaced on site. So very small, just a little bit of silicon seal causing a big failure of the whole glass unit. Now, what we also see quite often, it's the optical quality of glass. Here we have relatively highly reflective glazing, so the reflection of the glass is important. So we see all sorts of roller wave distortion, bowing of glass in and outside. So we need to quality control the glass before it comes on site. So we do all these kind of checks on flatness of the glazing, quality of the glazing. Is it bowing? Is it roller wave? We do stress testing of the glass surface. So is the glass properly tempered? We have all sorts of inclusions within laminated glass. We have edge delamination. Also, this happens all the time. You need to check it. There need to be specialists on site checking these things. We do mock-up testing. We test prototypes of our facades at early stage with a big aeroplane edging. We spray the facade. We're looking for water leakages. And even over there, we see things going wrong. You see over there, it's silicon not applied properly, meaning that water comes from the outside to the inside. So all these things do happen, and someone has to be there checking these things, pushing the contractor, make it right, make it good quality. This also brings us to the next topic of site inspections. And I think this is video number 2, if you could start this second video. This shows a unitized facade mullion after a couple of years. And this is an item that we're getting more and more clients coming to us and asking us for expertise because they have a so-called okay, that's fine. So we call it movement-generated noise, and we have a couple of projects where clients are very unhappy because the sunset comes, the facade heats up during the morning hours, the facade panels do expand, and then at these movement joints, at these so-called stack joints, actually our facade panels start to expand. You can hear, I mean, you heard just the kind of noise, this kind of noise was happening. So we have a lot of projects right now, I think it's 5 right now, where clients came back to us, say we have problems of noise in the morning. So the facade starts cracking, people just check down and again a noise comes up. So this is a problem that's mainly caused by some buckling clips, improper design, not a good testing. So just showing the importance of things. So we then go on site with specialist equipment going into the cavities within the facade, checking the cavities, is there silicon, is it all properly done? We see all sorts of bad things. You can see over here, facade brackets, excessive shimming, no load transfer. Some welding over here, not properly welded through the whole thickness of the steel. So all these things are actually unsafe, and someone needs to check it on site. Brackets over here, no washer, so this will slip with the first wind loading. You can see boards not being torqued properly, out of position boards, fixing boards. We see complete unitized facade panels hanging in the air, not fixed boards. I mean, all of these photos are actually real photos on site. What we also do, I'm going to be quick on this, was research and development, a lot of glass frame facades. Just a minute, going to be quick. Glass frame facades usually have circular fixings. And we asked, why are we not going to have a structurally more efficient fixing system with these elliptical shapes over here? So actually, we had the idea, we did get it tested, analyzed the kind of stress levels over here and here. This is a kind of prototype mock-up, and we found out that the structural capacity of these elliptical fixings are about 30% higher as of the circular fixing. So just a small idea, getting it tested, getting it done, and getting it actually built on site. Now this brings me back to the kind of topic, where are we going to be in the future? What's actually our future facade? Is it going to be switchable glazing, going to be double skin? What's the kind of future of our facade? And a lot of people have this thing in mind. This is the future. Super tall, high-rise buildings going on, and it's one side of maybe the future of super tall buildings. Other people have the idea of getting our buildings back to kind of more human scale, more kind of smaller scale, making curved buildings. And I'm going to tackle the one on the left-hand side. This is designed by Professor Werner Sobek. Kind of idea that people live just in a glass shell, a kind of monospace glass shell. So we like to be exposed to the outside. So this kind of glass shell is then doing all of the jobs, solar shading, thermal comfort, protecting you from actually from the external like environments. And this is a kind of photo from the inside by Professor Werner. So we can see it's a pretty challenging design, just a kind of glass shells, completely self-supporting, no steel framing. I mean, this would need a kind of switchable glazing, vacuum glazing, or the latest technology. I just want to show you maybe the future starts already now, because this is a built example of a friend of mine by Mr. Lucio Blandini and his PhD thesis in Stuttgart, Germany. So this is a glass shell, about 8 meters span with a titanium outer tension ring. So this is just glass. So glass is taking structural function. So the glass is not an infill panel. So glass is the main structural outer shell of the skylight. And actually between the glass panels, you just have a little bit of structural joint. It's not silicon, it's a more like advanced material. But just what I'm saying, just looking at this and this, people think this is the future, this is now, so maybe the future is now. Thanks a lot.
Thank you, Benjamin. We now look forward to a very interesting, different kind of subject, more on sustainability, from Technal, from their managing director who has 45 years experience.
35.
Oh, 25. I would say more than 25.
35.
35 years. And this is to invite Jean-Marc Luisto. Please give him a big hand. And most of you know him here. Some of you use his systems. Some of you are going to use his systems. Over to you, Jean.
Thank you. So, good morning, ladies and gentlemen. It's quite an impressive audience. Huh? First of all, I would like to thank Zach for giving me the opportunity today to share with you some of our thoughts regarding the building systems. Technal, I guess, or I hope that most of you know about us because we have been in this region supplying and selling a building system for almost 40 years. But what some of you might not know is that Technal is belonging to a very big group called SAPA. This group, SAPA, is the merge between the downstream activity of Norsk Hydro, which is a big aluminum company, and SAPA. And this group, which is about 23,000 employees in the world, with a turnover above $5 billion, is having more than 190 presses in the world. So it is the biggest extrusion group. And we are part of this group, and we are in a division which is called Building System. And the building system itself, it's about 90,000 tons of aluminum building systems sold per year, with 3,200 employees, nearly 1 billion euro turnover. And we are present in most of the countries in the world. Okay. So, where I want to take you today is as it has been said previously, the world is changing, and the world of the construction and of the building industry is also changing very fast. And what we have been doing so far, which is supplying a good system, for sure will not be sufficient. In the world of tomorrow, we will have to provide maybe more technology, and who says more technology says more training and more support. We will have to supply maybe more IT system to support our product, more automation. And it means that our business model, from being a system supplier, is evolving into a business model in which we will be a solution supplier. I like quite the picture at the bottom here, where you can see how much the consumption of energy has improved within the 45 past year. If you take the picture in the 1970, we were about 3.7 billion human beings on this planet. Nowadays, we are more than 7.5 billion, and most of us are living in the big urban center, in big city, and you can see the impact of the energy consumption seen from the space. And in that consumption, in that energy consumption, the building industry has a big impact, and the buildings have big impact. There have been some study that are showing that the buildings are using 12% of the water resources. 39 they are providing or delivering 39% of the CO2 emissions. They are generating 65% of the whole waste output. And last but not least, they are consuming 71% of the electricity consumption. And there are also some studies which show that with the technology that we are having today, that we are using today, we are able to make some improvement in all these areas. Energy use, by building in the right way, we can reduce by 1/4 to one half of what we are consuming. CO2 emission, we can reduce by 1/3. And the same for water and for solid waste. If you look at the impact of the building envelope, and the impact of the building, first of all, 30% of the world energy demand is used to construct and to run and to use and to operate the buildings. But in this 40%, 80% are not for the act of constructing the building, but for the act of managing and of using the buildings. And even with the energy which is embedded in the material we are using to construct the building, the construction act is only using 15% of this energy. Most of the energy is used in in the way we are running the buildings. And to that, we estimate that the building envelope is impacting more or less 55% of this energy demand through what it can bring or take in the lighting, and through what it can add or reduce in terms of heating and climatization. Whatever the what is the role which is played by the facades and by the facades in this picture? We've made some study, and whatever the facade of what the system that we are using, between a low efficient facade and a highly efficient facade, you can have naturally a difference of temperature in a room which is going up to 6 degrees. And when you know that 1 degree less in a room temperature can reduce the energy consumption by 5 or 10%, it means that we have a lot of potential for reducing the energy consumption in the facades. What are the key factors of the efficiency of the facades? The first one, of course, is the product. The product itself, the facade itself. And we can see that in Europe, where from the middle of the 90s, the governments have started to regulate the performances of the product, and then later on the performances of the building itself. There has been a strong improvement, in fact, in the performances, and which has obliged all the industrial that we are to develop and to market more and more sophisticated product with more and more efficiency when it comes to energy saving and energy consumption. And what I would like to say is that we have today the products available to suit the most stringent regulation in terms of energy saving. For example, with this kind of product which I am showing here, which has some part of our product offer, then in Germany from this year, from 2015, the requirement from the government is to have passive